Lorna Williams, a trained mathematics teacher. Welcome back to my channel, Bloom Your Math, and A is your grade. Today we will learn how to solve simultaneous equations using a matrix method. So, stay tuned. Okay, so today we are going to be learning how to solve simultaneous equation using a matrix method. But there are some things that you need to know before we solve simultaneous equation. So, here goes. You need to know that this is called an identity matrix or a unit matrix. It's a 2 by 2 matrix, two rows, row 1, row 2, and 2 columns, column 1, column 2. 2 rows and 2 columns. It's a 2 by 2. Alright, and we're just looking at the 2 by 2 matrix for the C6 syllabus. Notice that the main diagonal is 1 and there's 0 elsewhere. So that's called an identity matrix and it behaves like the number 1. So we know that 5 times 1 is equal to 5. So let's see where we go from here. Alright, we have a little pull up here, but let me fix the y-axis and the x-axis. So this point on the y-axis is 0, 1. And this point on the x-axis is 1, 0. The distance from the origin, 0, 0, to 1, 0 is just 1 unit. To the right, 1 unit up. Okay? So this is 1, 0, and this is a coordinate or a point. 0, 1 is also a coordinate or a point on the graph paper. Recall that if we have 1, 2, 3, 4, we read out the values on the x-axis first. So this point here, that point is called 2, 3. 2 is the x-coordinate and 3 is a y-coordinate. Remember that 2, 3 is not the same as 3, 2. For 3, 2, we first find 3 on the x-axis and go straight up to 2. So this point here is 3, 2. So they're not located at the same place. So where do we find 1, 0? 1, 0, again, we read off the x-axis first. So it's 1 on the x-axis, and the horizontal line is the x-axis, and we don't go up nor down, we stay same place. So this point A is 1, 0. That point A is 1, 0. 1 on the x, we read out the values on the x-axis first. Now this point is 0, 1. The red point is 0, 1. We read off the x-axis first. So you know the y and the x-axis is a number line. Both lines meet at 0, 0. So this is 0 on the x, and we go straight up to 1. This point here is called 0, 1, and that's a point or a coordinate. Now don't be confused now. A is 1, 0, but written as a position vector, which just tells you how to move in a specified direction. A is if we're moving one place to the right and One place to the right is just where we're going to end here. Okay? At 1, 0. The column tells me how to move. When the numbers are written side by side, it's a point on the graph paper. 0, 1 tells me I'm going in this direction. Okay? And the length of that vector is only 1. The length of this vector here, of both vectors are 1. The length of both vectors is 1. Alright? So 0, 1 is a coordinate side by side, but as a vector, it's 0, 1. Meaning, you neither go neither to the left nor to the right, but one place up. So when I put A and B together as position vectors, they now become an identity or a unit matrix. So this A, 1, 0, as a coordinate, I would have had 1, 0 on the graph paper. But as a vector, as a movement or a direction, it has a length in a specified direction. I would write it as 1, 0. B is 0, 1, but as a vector, column vector, it's 0, 1. Put them together and we get what we call a unit vector. So 1, 0, 0, 1 behaves as the number 1 as we said earlier on. So if we have any matrix and we multiply it by 1, 0, 0, 1, what do you think we'll get? If I have a matrix 2, 3, 4, 5, and I multiply it by 1, 0, 0, 1, and if this behaves like 1 in a normal multiplication, then what is the final answer when I multiply? What do you think? Yes, you'll get back the given matrix 2, 3, 4, 5, because a matrix times its identity will always give me back that matrix. Similarly, if I do the reverse, I times A will give me back A. So any number times 1 will give me back that number. Just like 5 times 1 will give me back 5. A matrix times 1, 0, 0, 1 will give me back that matrix. So the matrix is A and this is I, then you will always get back A. Doesn't matter what 2 by 2 matrix you have. Now solving simultaneous equation is really where we are heading, and you need to recall many of the concepts that we learned earlier on. So here's a question. Solve the following simultaneous equation using a matrix method. Now many of you, especially those who have left school for a long time and you're reviewing simultaneous equation, might just need to remember what it means. If I have, say, x plus y equals 10 and x minus y equals, say, 8. Now, can you guess what the value of x and y? What's the value of x and what's the value of y that will satisfy both equations? You can pause the video and think about it. X plus y equals 10. Now, if you said 9 plus 1 is equal to 10 and 9 minus 1 is equal to 8, you are correct. the value of x is equal to 9 and the value of y is equal to 1. And these answers satisfy both equations, equation 1 and equation 2. These answers are true for both equations. So if you had said 7 and 3, then that would be wrong. Because 7 plus 3 is equal to 10, that's for sure. 7 plus 3 is equal to 10. But 7 minus 3 is not equal to 8. So the value of x has to be 9 and the value of y has to be 1 to satisfy both equations. But now we're using, and there are several methods, you know. We use the elimination method, substitution method, the graphical method. But today we're going to be learning, because the topic is matrix or matrices, singular matrix, plural matrices, we're going to use a matrix method to solve simultaneous equations. Okay, so let's go. Solve the following simultaneous equation using a matrix method. It's not too easy to guess the answer or the values for x and y here. It will take you some time to figure it out. The one I gave you earlier on, x plus y equals 10, x minus y equals 8. It's easy to figure that out. You could guess that, you know. But this will take some time. But there are some steps that we can use in order to arrive at the answer. And I'm going to take them step 1, step 2, step by step. Step 3, step 4, step. Okay. So step 1 says rewrite the equations in the matrix form AX equals B. That's step 1. What does it mean? That we're going to separate the numbers from the letters. So this is the first matrix here, 5, -2, -11, -3 is called matrix A. The variable is called X. And the 2 by 1 matrix after the equal sign is called B. Now, on some CSEC paper, you see CX equal D. It means the same thing. That this will now be C, and this is D. So it doesn't matter what letter they use. Don't let that confuse you. So I'm going to write what I have here in my step. The letters I'm going to use are A, X, and B. Now, to solve a simultaneous equation, this is a formula. And I'm going to get a bit into the reasoning part of it as we go on. So, highlight this in your book, make a note. This is how you solve simultaneous equation using a matrix method. The formula is xy is equal to a to the minus 1 b. Now recall in our previous video that a to the minus 1 stands for the inverse of a matrix, okay? And there's a formula for the inverse of a matrix. Anyone remembers? Huh? Those who do an exam next week, do you remember? Alright, let me remind you. It's 1 over the determinant multiplied by the adjoint. So please check out my previous videos. I'll link it in the description box below, just in case you missed that video. Alright? And we're moving on now. So again, to solve a simultaneous equation, the formula is a to the minus 1 times b. And what do we call A? This matrix. What do we call B? what comes after the equal sign. So we're going to find the inverse of A and multiply that answer by B. So work with me now to find A to the minus 1, which is the abbreviation for inverse. Recall that we said the inverse is 1 over the determinant times adjoint. And the matrix A is 5, negative 2, negative 11, 3. So let's make a note of that. 5, negative 2, negative 11, 3. Okay, this is the matrix A. So we're trying to find A to the minus 1. How do we find the determinant? Again, our main diagonal is 5 and 3. 5 to 3. So we're multiplying, so it's a product of the main diagonal, 5 times 3, minus the product of the minor or the non-leading diagonal. So this is the main diagonal or the leading diagonal. And the other one, the other diagonal, is the minor or non-leading. So we're multiplying these two together. And here's a minus sign between them. So 5 times negative 3 is negative 15. Negative times negative is positive. Here's a minus sign. So negative 15 minus 22 means the same thing as negative 15 plus a negative 22. You owe 15 and you owe 22, you owe 37. So the value of the determinant is negative 37. The next thing we need to do is, so we found the determinant, so what do you think is next thing? To find the adjoint. And there are 2 steps to find the adjoint. Focus again on the question. Focus on the matrix A. The matrix A is 5, negative 2, negative 11, 3. Do you remember the 2 steps that we need to find we use to find the adjoint? Yes. We switch the elements in the main diagonal. Alright, so we have 5, negative 2, negative 11, 3. And I'm going back to 5, negative 2, negative 11, negative 3. So we missed off the negative 3, didn't we? Alright. Here we go. So we corrected that. Because all my answers are here already, you know. I worked them out long before, so I'm now explaining. And when I see something funny going on, I have to go back and check. That's what maths is all about. We make errors and we have to go back and check. Okay? Alright, so we have the matrix A was given to be 5, negative 2, negative 11, negative 3. And so there are 2 steps to find the adjoint. Step 1, we switch the elements in the main diagonal. So they switch places. So negative 3 comes up here and 5 goes down there. This is what we have. Are you with me? Alright. Negative 3, switch places with 5. And step 2, we multiply the other 2 elements by negative 1. But they keep the same position. They don't move. So negative 1 times negative 1, negative 11 times negative 1 is a positive 11. And negative 2 times a negative 1 is a positive 2. So basically these two change signs. These two change signs and these two numbers switch places. That's how we calculate the adjoint. And let's put them together now, because the formula says 1 over the determinant. So it's 1 over the determinant. Now the determinant is negative 37. Follow me closely now. The determinant is negative 37. So why is it that I have a to the minus 1 is equal to negative 1 over 37? Why do I have that? Because negative divided by a positive is equal to a negative. So the whole fraction is negative. So if I have a negative in the denominator, it is also the same as saying that I can simplify to give the whole fraction a negative value, because a negative divided by a positive is a negative. So 1 over negative 37 is the same as negative 1 over 37. You get that? Times the adjoint. Now, it is better to leave the answer in this form instead of working with fractions, because everybody knows now how to multiply two matrices. So, leave the answer in this form. You don't need to use a scalar and multiply it by each element. Negative 1 over 37 times negative 3. And working with fractions is a lot more work. Okay? However, please note that they can give you in fractional form as well. So in our Take 5 series, I will give you one where we reduce this to fractional form. Alright, so we are on to step 3, and we have already separated the numbers from the letters. But please note that it's not just automatically pulling them away. They really mean the same thing as the question. Because if you check it out, row 1 is 5, has element 5 and negative 11. That's row 1. And column 1 is xy. So if we multiply first with first and second with second, we'd have gotten 5 times x is 5x plus negative 11 times y is negative 11y. But I hope you know by now that a plus and a minus combine to give you a minus sign. So in essence, this form, the way this form actually means the same thing as this. Let's do this bottom row. Negative 2 times x is negative 2x. First with first, second with second. Negative 3 times y, negative 3y equals 8. So they mean the same thing. Now, I'm going to put an asterisk here to show you that this is something that you need to remember. It's a formula for solving simultaneous equation. And how did that formula come about? Basically, if you have a matrix A, x equals b, A times x equals b, and you want to make x a subject. This is a matrix, you know, and this is a matrix. Basically, what we're actually doing is pre-multiplying both sides by the inverse. In order to make x, leave x as a subject. Alright? So, here we go. And I'm putting the inverse in red, because I'm going to explain a little bit. Whatever do we do with one side, we do it the other side. Okay? Remember, the original question is ax equal b. And if I want to make x a subject, I need to get rid of the a, obviously. Now in matrix, all I need to do is to pre-multiply both sides by the inverse. Now, this is an important concept now. If I multiply the inverse by its original matrix, I will get the identity matrix. And remember what that is? 1, 0, 0, 1, which behaves like 1 in ordinary multiplication. So if I multiply these two and it gives me 1, then 1 times x gives me x. So I'm left with x as a subject. So this behaves like 1 in normal multiplication, so we end up with 1x. Again, a to the minus 1 was never in the question. I put it in on the left. So if I adjust the sign of the equal sign, I've got to adjust the sign on the scale here. I have to put a to the minus 1 on both sides. So how did we arrive at this formula now? Since this is the same as 1, 1x, we're saying that x is equal to a to the minus 1 times b. That's the formula for solving a simultaneous equation. We're actually multiplying both sides by the inverse to make a the subject, x the subject. Just like how you know 2 times a half is equal to 1. The multiplicative inverse of 2 is a half. Okay? So a number times its inverse is going to give you 1. This times its inverse is going to give you 1. Alright. And remember that we wrote ax equal b. This really stands for xy equals a to the minus 1 times b. So that's a breakdown of how we arrive at the formula. So back to the question. A to the minus 1 is 1 over the determinant times the adjoint. And the b is 17 and 8. A 2 by 2 matrix, that's b. This is a, x equals b. So b is 17, 8. Alright? So again, it's easier to multiply the two matrices first. And why is that? It does not matter which two elements which two numbers you multiply first. If I have 2 times 3 times 4. If I multiply 2 times 3, I'll get 6 times 4, which is 24. If I multiply 2 times 3 first. If I multiply 3 times 4 first, I'll get 2 times 12. I still get 24. So what this is saying is that I don't have to multiply the fraction with the first matrix first. And let me erase that so it's clear to you. And I'm going to write it much bigger over here. Negative 137 times, that's what it means, you know. Negative 3, 2, 11, 5 times 17, 8. I prefer to multiply the two matrices first. Are you with me? Because once I get that answer, I'll simply multiply it by the fraction, negative 1 over 37. And let's go row by column. And I'm using arrows this time. So that's row 1 times column 1. One column really. So negative 3 times 11 first with first, plus 11 times 8, second with 7. And our answer is a 2 by 1 matrix. How do we know? This is a 2 by 2, and this is a 2 by 1. So they can be multiplied, they're compatible, and the outside tells me my answer size. Okay, so the second row is 2 times 2 and 5 with 17 and 8. You get that? So I'm multiplying 2 times 17 plus 5 times 8. Now we're going to tidy up things a bit. Negative 3 times 17 is negative 51, and 11 times 8 is 88. 2 times 17 is 34, 5 times 8 is 40. When I simplify what is in the bracket, negative 51 plus 88, you have $88, and you owe 51, you're left with 37. And 34 and 40 is 74. So now we're going to multiply negative 1 over 37, which is a scalar fraction here, by 37/24. Alright? Just so that you are clear, let me do a big write-up over here. We have negative 137 and 37/74 in the matrix. This is a scalar. So we are going to be multiplying negative 1 over 37 by each element in the bracket. So that's the top value. And you know 37 is the same as 37 over 1. And negative 1 over 37 is to be multiplied as well by the 74. And we can cancel. 37 into 37 goes one time. And this is a negative 1 over 37, so don't forget that. So your first value, or the first value here, which is the x value, is negative 1. The second value, 37 into 74, goes 2 times. 2 times negative 1 is negative 2. So the second value is negative 2. First value is negative 1. Second value, negative 2. I just expanded this for you. So this means the same thing as what you see there on the right hand side. Negative 137 times 37, negative 137 times 74. So that's it. That's how you solve it. So the formula again is a to the minus 1 times b to solve simultaneous equation, in order to find the unknown values for x and y. Our formula is a to the minus 1 times b. We can check if our answer is correct by substituting these values into the equation. And if the left hand side gives me the same value as the right hand side, then you know you have not made a mistake, and you'll get full marks for this answer. And I'll just do one for you, but you can check the other when you have a little time. It says 5x minus 11y equals 17, and we said that x is equal to negative 1 and y equals negative 2. That's what we found the values of x and y to be. Remember, 5x means 5 times x. So it means that we are multiplying 5 times the value of the x, which is negative 1, minus 11 times the value of y, which is negative 2. Now, we're not sure if it is 17 as yet, you know. We are checking to see if our answer is 17. If it is, then you know that the values for x and y are correct. So 5 times negative 1 is negative 5 minus 11 times negative 2 is negative 22. 2 minus signs combine to give me a plus. So now we have negative 5 plus 22. You have $22 and you owe 5, so you're left with 17. Ta-da! 17. So I love to draw my scale. So 17 pounds of sugar on the left hand side will give me, is the same as the 17 pounds of sugar on the right hand side. To maintain the balance, my scale is balanced and my answer is correct. Don't just check for equation 1 alone, please check for equation 2. And if Your answer, when you substitute x equals -1 and y equals -2 in equation 2 and you get 8, then you know if this question is for 6 marks, you get your full 6 out of 6. Alright? Okay. Provided you don't make any minor mistake elsewhere and they take off only 1 mark. That won't kill you too tough. Okay, so our answers are x equals -1, y equals -2. We have just solved simultaneous equation using a matrix method, and the formula is to find the value of x and y. We use the formula the inverse of A times B. Remember the steps for the inverse? 1 over the determinant times the adjoint. And B is a matrix that comes after the equal sign. It's a 2 by 1, 2 rows, 1 column here. That concludes today's class. I post videos weekly, so if you like this video, please don't forget to like, share, and subscribe. You may ring the notification bell below to alert you when I upload new videos. So, see you next time, and bye for now.